So today I'm going to start off with algebraic equations just for the first few minutes of the lesson and inequalities. So let's hear, what do you remember about solving algebraic equations and inequalities? And participate, says Chaparo. Yes, and participate. Gabo Entle, welcome. Welcome, welcome. Okay, let's talk about solving algebraic equations. So let's check what we have here. Number A, we have 2x minus 1 is equal to negative 9x plus 6. Remember, if you're feeling confident, you can raise your hand and we can talk about it. Hi, Princess. All right. Anyone remember the rules? Anyone want to remind us of the rules? Anybody? Should I do the first one? Teacher Coco is not here just today, but Teacher Coco will be back as soon as possible. Okay. She will be back as soon as possible. There we go. We have a volunteer. Anno. Hi, Anno. You may unmute.
Hi, ma'am.
Hello. Are you going to solve this with me?
Oh, sorry. No, I can't see what's going on because you're okay. My screen is black and I can't see what's going on in there.
You cannot see my screen.
Okay.
Yes.
Can you please try to go to
like share it again with the classmates?
I mean, it's on. I think Nelisa can see. I think everyone can see this.
So Anatida, if you can't see the screen, go to Teacher Kat's video feed and right click on it and then unpin or uncheck the option pin.
Oh, I see it. Thank you very much.
Teacher Kat's video feed. Yeah.
Thank you.
All right, fabulous. Fabulous, fabulous. Okay, let me do the first one for us, just to remind us how we do these, okay? Remember, we want the variables on one side and our exponents on another side. Okay, in this case, because this is a linear equation, so we want to separate our variables and constants, okay? So this 9x, negative 9x, will have to go to the left-hand side and join our 2x, and this negative 1 will go to the right-hand side and join our 6x, okay? So let's see. So on the right left-hand side, we have our 2x. Never mind, my pen did not cooperate for 2 seconds there. I don't know what happened. Okay, there we go. There we go. My pen today is not having it. There we go. So we have a 2x, negative 9x. When it gets to the left-hand side, it becomes what? Negative 9x goes to the left-hand side and becomes what? Anyone? Let's participate, guys. Come on, come on, come on. Positive. Thank you, Isabel. Thank you, everybody. So it's plus 9x. And on our right-hand side, we have a 6 and 1 was negative, so it becomes positive 1. And now we add our like terms. What is 2x plus 9x? What is 2x plus 9x, everybody? 11x is equal to 6 plus 1, which would be 7. Now what? Who knows what we do from here on? What did we do from here on? We have added our like terms. And now what do? We want to get rid of that coefficient. Yes, we divide by the coefficient to get rid of it. So we divide both sides by 11. And therefore, x is equal to 7 over 11. Okay, looks like we remember this, all right? This is just touch-ups to see if you guys remember this. Okay, let's do number B. Number B is the same concept, right? Let's see if anyone wants to help me with this one. Kamo, do you have a question? Do you want to help me with this one?
Hello, ma'am.
Hello, Kamo.
How are you today?
I'm well, and you?
I wanted to do number B.
Let's do B, Kamo.
So we're going to start by putting like terms together. So we're going to say 6x minus 3x.
Beautiful.
Which is going to be equals to negative 2.
Negative 2.
Plus 1.
plus 1. Beautiful. Now let's add our like terms.
Which this is going to be 63x.
3x is equal to how much?
Which is equals to -1.
-1. And then?
We're going to like say over 3 on both sides.
By 3 on both sides. Therefore, x is how much, Kamu?
X equals to 1/3.
-1/3. Don't forget that negative. Thank you very much, Kamu. That was nicely done. All right. So we have done those that are linear. And now we move on to quadratic equations. These are a little bit different, right? Now we have to find our factors. Now we have to find our factors, okay? That was beautiful, Kamu, beautifully done. Who remembers how to do the quadratic equations? Okay, we have to factorize this one first. See, I already gave you guys the first step. Who remembers how to factorize these? Mamello, let's see if Mamello remembers. Yes, Mamello.
No, ma'am, I don't understand this one. I just wanted to ask for the first ones that we did. We are solving for x.
Yes, we are solving for x.
Okay.
There we go. Okay, guys. Yes, it's a trinomial. So we have to make 2 brackets. Is there anybody who knows what my 2 brackets are so far? Anyone who's figured it out? We have our 2 brackets equal to 0. Let's see what Rafilo has to say. Rafilo?
Ma'am, can I help?
Yes, you may. Let's hear what you got.
We times x squared and -4. We look for their factors.
Okay. And what are the factors of x squared?
It's x times x.
X times x. X times x. Okay, let's go to -44.
The factors of -44 are 1.
1 goes with?
1 goes with 44.
There we go. And then?
2 goes with 22.
22.
And then
Do you think 3 can go into 44? I don't think so.
I'm not sure. My calculator is not working properly.
Let's talk about 4. Do you think 4 can go into 44?
Yes.
How many times?
Um.
Let's think about multiples. Let's hop out in the chat and see if people are helping out. There we go.
11.
Someone is helping. There we go. 11 times.
11 times.
Are those all our factors of 44?
Yes, I think that's
Okay.
all.
All right, now let's talk about the signs inside the brackets, which are going to be my 2 symbols in the brackets.
In the first bracket, it's gonna be positive.
Positive. And my second one?
Negative.
Negative. Beautiful. Now we have to find a positive and a negative number that add up to positive 7x.
7 and
Yes. So tell me, out of 1 and 44, do you think we'll ever add up to 7x?
no.
Nope. 2 and 22?
No.
Nope. 4 and 11?
Yes, if you minus them.
There we go. So which one is positive and which one is negative?
-4 and positive.
-4. Beautiful, because 11 minus 4 will give you 7x. Now we factorized it. What's next? Now we have our factors. So where do we go next?
Hi, ma'am, I don't know.
We split them. Remember, you factorize and then you split.
Split.
So you're going to say either the first bracket is equal to 0. So either x plus 11 is 0 or x minus 4 equals 0. Do you remember now?
Yes, just a little bit,
Beautiful.
ma'am.
And now we're going to solve them separately. So what's my first solution for x? for x plus 11. What's my solution for that?
It's gonna be x minus 11.
X is equal to negative 11, or x is equal to?
Negative 4.
Look carefully. When the
Or
4
x
goes
is
over,
or x is equals to or x is equals to 4 or 0.
4, positive 4. Remember, this negative goes over and becomes positive. Do we remember?
Yes.
Beautiful. Thank you very much for going through this one with me, Refilwe. That was beautiful. Okay. I think we're going to have to spend some time on my inequalities, okay? Because this was supposed to be revision. Okay, let's go to inequalities. Who remembers how to solve inequalities? Anyone have an idea? We've done it with 0. The only difference now, guys, is that we have an inequality instead of an equal sign. Okay, so we have an inequality instead of an equal sign. So look there. So if you had an equal, what would you do? Let me say it like that. If you had an equal sign, what would you do? Step 1 is, no, we're not doing D because I'm looking at the time. We need to get over to today's actual lesson. Okay, Chafaro. If you had an equal sign there by A, what would you do, guys? We have 3x plus 4. Hi, Balisa. Is less than or equal to 5x minus 8. So if you had an equal sign, what would be your first step? Ande, let's see what Ande has to say. There we go, Lindobuhle. Yes, Ande.
Would we say 3x plus 5x is less than equal to negative 8 plus 4?
Close. But remember, when the 5x goes over, what happens to it? If it was positive, it becomes?
Oh, it becomes negative. Yeah. Okay.
You were very close, hey? You were very close. So it's actually going to be 3x.
3x minus 5.
Minus 5x is less than or equal to negative 8.
Would you
4 goes
say
over.
minus 4?
There we go. Beautiful. Now let's add like terms. What's 3x minus 5x?
Negative 2x.
Negative 2x is less than or equal to negative 8 minus 4.
Negative 12.
Negative 12. Negative 12. Okay, now what?
And then we divide by negative 2 on both sides.
We divide by negative 2, divide by negative 2. Therefore,
X is less than equal to 6.
Oh, we need to remember something. Who remembers something about inequalities? What happens when you divide by a negative, guys?
Oh, we swap. Sorry, we swap.
Yeah, changes around. So now it becomes
so
greater than or equal to 6.
Oh, okay.
That was
Thank
close.
you.
Thank you very much, Andy, for helping me with that one. Beautiful. Beautiful
Thank
stuff.
you.
Okay, guys, remember when you divide by a negative when you're doing inequalities, your sign changes. So if it was a less than sign, your crocodile faces the, okay, my hand wasn't working. Your crocodile faces the other way. So if it was that way, it goes the other way. If it was that way, it goes the other way. Let's hear Didi. Didi, are you gonna help me with the next? If you have a question.
Ma'am, I have a question. Oh, ma'am, there was like, I already wrote my papers, both of them. Ma'am, in the test, they had like one where it's 3, like in one. You see like how we have it here on
Oh,
A?
and then there was another one like on this side, like a less than 4, something like that.
Yes, ma'am. And like
Okay.
it confused me so much.
So Didi, in that case, whatever you change on one, you change on all of them. Okay. So let's say you're subtracting 4 here. Remember, you're subtracting 4 actually to get rid of it. You're not moving it. You're actually technically subtracting 4, right?
Okay.
So you would have to subtract 4 there. and then you would have to subtract it there, and then you would have to subtract it on the third side as well. So you do it on every single side. And then if you divide by -2, you divide by -2 here and here and here, and then all your signs will change. Okay, so you see both of these are facing the same way, so they would both turn around and face the other way.
Okay, thank you, ma'am.
You're welcome. All right, let me go down and see what was that. Okay, we're doing exponents today. Let's do one of exponents. Let's do one of exponents. Anybody know how to do these ones? I know these ones are nobody's friend, but it's fine. Guys, remember you can do this. How do we solve exponential equations? Remember, this is just revision, okay? This was just a brush up of equations that you should have done according to teacher Coco, okay? I'm just following instructions. So let's do B. Let's do B. If this is haunting you guys a bit, let's do B together. Anybody have an idea of where we would start with B? Remember, we want two bases that are the same on both sides, okay? It's not the wrong class, Kimotloto. Teacher Coco is just not well today, okay? Okay, we can do A. We can do A, Ano. Let's do A. Let's do A. So we want the same base on both sides, okay? Take the bases out, sort of, okay? Let's check what we have here. So we have 4 times 3 to the power of 3x plus 2 plus 3 to the power of 3x plus 3 equals 7. All right, so we want to isolate these x's that are in the exponents. Okay, so what we can do is A, split this up. Okay, remember laws of exponents says when you multiply, you add the exponents. So then you would have a 4 times. I'm splitting this 3x. I'm splitting this 3 to the power of 3x plus 2, and I'm making it to 2 bases. So it's going to be 3 to the power of 3x times 3 squared, and then plus. Okay, splitting the second one as well, doing the same thing. 3 to the power of 3x times 3 cubed equals 7. I know I might have lost some of you guys. That is law number 1 of exponents. All right, that is law number 1 of exponents. And now we can take it out. Whoever said we can factor it out, that was true. So you can take out 3 to the power of 3x. Tell me what is left on the first term. Here, first term, there's our first term. If I take out 3 to the power of 3x, what are we left with? Tell me in the chat, what are we left with? Okay, Sipogazi. This is why I wanted to do number B. Okay, this is supposed to be revision, but it's fine. Let's start over. Remember, we want the exponent that has the x to be on its own. All right, so in this case, it would be this one and that one. Right? So what I did was I split it. Remember the first law of exponents said what? If you have something, oh geez, I thought that was my pen, sorry. If you have 2 bases that are the same, let's say 2 to the power of 4 times 2 to the power of a, you can add the exponents. It'll be 4 plus a. So I'm going backwards. Can you see that these exponents were added? So I'm going backwards and splitting them up so that I can take out 3 to the power of 3x as a common factor. Okay, so I just took it out as a common factor, all right? Yes, so when you take it out, thank you, Mamelo, what is left on the first term? That would be 4 times 3 squared plus. What is left on our second term when we take that out? If you factor out 3 to the power of 3x, what would be left on our second term? That would be the yellow one or the orange one, whatever color that is. What would be left? Thank you, Ano. 3 cubed, right? And this will all equal 7. Now we have to work out what's in the brackets. 3 to the power of 3x, open bracket, 4 times 9, 9, 18, 36. And that will be plus 27. is equal to 7. What's 36 plus 27? I know that's such a weird question to ask, but my brain works very slowly sometimes. How much would that be? That would be 63, I believe. That would be 63, right? Yes. 63 equals 7. Whew. So now we want to get rid of anything around the x. So what do we do with that 63 to get rid of it? If you have 3 to the power of 3x times 63, how would we get rid of that times 63? Nope, we are timesing it. What would be the inverse operation of multiplication, Shafaro? Divide. Thank you, Kimutloto. So we would have to divide both sides by 63 to get rid of it. So 63, these two will cancel each other out, divided by 63. So now we're going to be left with, okay, I'm going to take the space on the B side. So now we're going to be left with 3 to the power of 3x is equal to 1 over 9, right? Now we want the same base on both sides. How can I rewrite 9 as a base of 3? How can I rewrite 9 with a base of 3, guys? In other words, what are the prime factors of 9? How do I rewrite 9 with a base of 3? Thank you. Okay, so this would be 3 to the power of 3x is equal to 1 over 3 squared. Now we want a base of 3, right? It's not a base of a third. So I'm going to do the inverse of law number, I believe it's law number 4, right? It's law number 4 that says if you have a negative exponent, you can do the reciprocal. Do we remember that law? Do you remember the law about the reciprocals? So instead of 1 over, oh yeah, you can do it on your calculator. You can do it on your calculator, okay? I'm just used to not using calculator, so it's a bit of a disease, but it's fine. So now we have same bases on both sides. Same bases on both sides. Why? How do we solve this, guys? Now it looks much, much better. We have 3 to the power of 3x is equal to 3 to the power of negative 2. If you have the same bases on both sides, you can drop the bases, okay, and make your exponents equal. Therefore, 3x will be equal to negative 2. Is that a 5 above the 2 squared? Where is the 2 squared, my dear? Okay, then you divide both sides by 3, divide both sides by 3. Therefore, our final answer is x equals negative 2 over 3. I know this one was a little bit complicated, guys, but if you rewatch this video, okay, yes, Oratilo, if you rewatch this video, I promise you, you will get it. Okay, you will understand everything that I have done. All right, okay, that was supposed to be revision and it has eaten through half of my lesson. But it's okay. Let's move on to today's work, which is exponents. I have just reminded you guys of the laws of exponents now. So let's see if we remember some of these laws of exponents. Okay, let's see if we remember. Let's talk about A. 7 times 7 to the power 4 times another 7. How would we do that using the laws of exponents? How would we do that? That means divide. Yes, Michael, we did divide. So how would we do A, guys? What does the first law of exponents say? Let's remind each other. If we are multiplying, what do we do to the exponents? We are multiplying, same basis. Yes, Oratile and Oratile. Woo, that was Kama. Let's hear what Kama has to say. Yes, Kama.
Sorry, ma'am. Don't you add them?
Yes, you do. So if there's no exponent,
Okay.
what exponent is it?
It's 1.
It's 1. So then this would be 7 to the power
of? 1 plus 4 plus 1, which is 6.
Thank you very much. 7 to the power of 6. Thank you, Kama. That was fabulous.
Cool.
Okay, Guys, we're not focusing on simplifying this. You have your calculator for this. We are focusing on the laws of exponents today, okay? So we're gonna just leave it as 7 to the power of 6. That was just to remind you guys of the law of exponents. And now we're doing the same thing, just using variables. So what's m cubed, or m to the power of 3, multiplied by m to the power of 5? How would we do that one? Same law, right? Excuse me, it's the same law we just used. So then what's my answer? M to the power of 8. Thank you, Ivana, because we're going to say m to the power of 3 plus 5, which will give us m to the power of 8. Okay, I hope we're still with me. This is today's lesson. I know, just check carefully that you added right. I think you had the right concept. You might have just added wrong. All right, now let's go to C. Let's go to C. What's happening there by C? Now we have a coefficient. What happens when we have a coefficient, guys? What happens when we have coefficients? Anyone? Shifaro, is there anything confusing you? You can raise your hand. Lishle, you're almost there, but remember we're multiplying and not adding. Okay, so if there's no coefficient here, similarly, in the same way, when there's no exponent, we assume it's a 1. This would be a 1, okay? So then you just multiply. You multiply the way you would numbers. What's 2 times 1, guys? What's 2 times 1? There we go, 2. That will be 2 to the power of m, 2m to the power of 8. You see that, guys? A nice way to remember this is symbol. My pen can cooperate. I can give you this nice term. Symbol, numbers, variables. So you deal with the symbols. In this case, we had 2 positives. A positive and a positive gives you a positive. Then you go to numbers. 2 times 1, that will be 2. And then you go to the variables. M to the power of 3 times m to the power of 5 is m to the power of 8. So just use the S and V to try and remember this, okay? If it confuses you a little bit. All right, let's see. Let's move on to D. This time we have 2 different variables. So do not confuse these variables. Each variable is independent, okay? Each variable is independent. So we have, I need to change my highlighter color. I've been using purple for the longest time. So we have a M, and we also have a N, okay? So be careful. You deal with these independently and separately. You do not add all of the exponents. Remember, the bases have to be the same. The bases have to be the same. Yes, so you first deal with m's. Let's deal with m's. If I deal with m, it's going to be m to the power of what? M to the power of what? Yes, 6, because it's going to be the invisible 1 over there, plus your 5, which will be m to the power of 6. And n doesn't have a companion, so we just rewrite it as n cubed. One mistake that I see very often in exams is we forget about the variable that doesn't have any friend. So don't do that. Don't write m to the power of 6 and then forget to write the m. Okay, guys? So far, we've been doing the same law over and over. Now let's see E. E has thrown in a little bit of a spanner in the works, right? This time we have multiplication, as we have been doing this all time. There we go, multiplication. But now they have added a little spice and put in division. Who remembers what we do when you have division? If you are dividing 2 things with the same base, what happens to the exponents? Let's hear.
Ma'am, I think like when you divide, you subtract your exponent.
That would be true. Do you want to do this one with me?
Oh, yes, ma'am, please.
Let's do it. Okay, so what should I write?
So it's 7 to the power of 3 plus 5 over 7 to the power of 6, which is equal to 7 to the power of 8 over 7 to the power of 6, then is equals to 7 to the power of 8 minus 6, which is equals to 7 to the power of 2, I think, yes.
Thank you, Gimotloka. That was beautiful.
Thank
That
you.
was beautiful. I see that we remember our laws of exponents. Okay, we remember our laws of exponents, and that is beautiful. All right, remember I said we're not focusing on simplification right now. So if you write equals 49, that's okay. But now we're just focusing more on the laws of exponents. Okay, that was beautiful, right? Okay, now let's check F. F, we're back with numbers again. So we're going back to S and V. Symbols, everything is positive. So we know our answer is going to be positive. Numbers, 8 divided by 3. We can't exactly do anything with 8 over 3. And then what's happening there by the variables? What's happening there by the variables, guys? Anyone know? Any ideas? Nope. They're not the same. They're not the same. Michael, be careful. They're not the same. So what happens if they're not the same? Can we do anything with them? No. So literally, we're going to rewrite this the way it is because you can't do anything about it, right? So this answer is literally 8x to the power of 3 over 3y squared. Okay, so your teachers will put this in a test to try and trick you, but you have to remember our one condition when applying laws of exponents, and that is that the base must be the same. Okay, so in this case, the bases were not the same. Base must be the same. So if your bases are not the same, you cannot simplify it. Okay, you just rewrite the answer the way it is. Yes, oratile. Okay. It's not undefined. Remember, undefined is only when you divide by 0, which we don't know if we are dividing by 0 because we don't know what x or y is. So if the bases are unlike, you cannot do anything about it. Laws of exponents cannot be applied. So you will literally rewrite the question the way it is. Okay, great. Now let's go back up. Let's do the rest of our questions. If I can go up. There we go. Okay, H. No, not H. G. Let's go to G. We have the same basis in this case, right? We have our same basis in this case. So how would we go about working out G? We have multiplication and division. Can I get someone to do this one with me? Hi, Amukhelang. No, you don't cancel them out. You just rewrite them. Okay. Okay, Shafaro says we add. Yes, we're going to add the ones in the numerator. And then what happens after we add? And then we're going to subtract. So let's start with Shafaro's idea to add. P to the power of 4 multiplied by P to the power of 6. So what am I going to have in the numerator when I add those? I'm going to have P to the power of 4 plus 6 over P to the power of 3, which is going to give me what? Yes, that is the answer, guys, because that will give you P to the power of 10 divided by P cubed. And remember, we are dividing. So that means we will subtract 3 from 10, excuse me. That will be P to the power of 7. There we go, guys. We remember our laws of exponents. We're doing well. Yes, you're not in the wrong class. Don't worry. Okay, Teacher Coco will be back soon. She'll be back soon. Let's check what's happening in H. In H, we have 2 different bases. We have 2 different bases. So let's hear. We have to deal with the 7 independently, and we have to deal with 3 independently. So now let's do that. What's happening there? So remember, 7 is a number, it's a base on its own. So we're gonna have 7 cubed times 7 divided by 7 divided by another 7. Or you can simplify the numerator and the denominator, then you simplify the whole sum. I recommend you do that. So let's do that. In the numerator, I'm going to have 7 to the power of what? Let's hear. In the numerator, yes, it is. Yes, it is. You're not lost, my darling. We are revising laws of exponents, okay? In the numerator, thank you, Mamelo. We're going to have 7 to the power of 3 plus 1, which is 4. If you think it's tedious that I'm writing this, don't worry. Please, guys, be patient. We're trying to go step by step to remind everyone who might have forgotten. Okay, we've dealt with the numerator. Now, in the denominator, we're going to have 7 to the power of what? In the denominator, we're going to have 7 to the power of what? Chifaro, be careful. How many 7s do we have in the denominator? We have 2. Do we see that? There's an invisible one there and an invisible one there. So it's going to be 7 to the power of 1 plus 1, and then multiplied by our second base, which is 3. So it's going to be 3 to the power of what? We're applying the same rules over and over. Thank you, Anotidaishe. Where am I? There we go. So this is an invisible 1, and it will be 3 to the power of 1 plus 2. Now let's simplify this. This will be 7 to the power of 4 divided by 7 squared times 3 cubed. Now we can deal with the 7s. We can deal with the 7s. What happens now? What happens now with the 7s? Yes, Chifara, that would be correct. Mbalenhle, thank you. We have to subtract, right? We have to subtract the exponents for 7. So then we're going to be left with 7 to the power of 4 minus 2 over 3 cubed. Therefore, my final answer would be 7 squared divided by 3 cubed. I saw someone said times 3 cubed. They have to be on the correct place. Okay, so it's going to be 7 squared all over 3 cubed. Are we fine so far? This is the first check-in that I'm having for today. Are we fine with the laws of exponents? I'm going to stop here before we do more complicated stuff. If we have questions, let's raise our hand now. Give me a thumbs up, thumbs down. How are we feeling about these laws of exponents? We've done them before for a few years, but I know it's easy to forget these. I see in the reactions those thumbs up. Yes, it does. It gets more complicated. Okay, I see thumbs up. If you do not understand, please raise your hand and I will stop and explain to you, okay? That's why we're here, to try and help us understand better. Okay, I'm seeing thumbs up, so I'm happy. Yes. What if the exponent is a variable? Good question, Ayanda. You keep following the laws. So if I have 7 to the power of A multiplied by 7 to the power of B, let's say over 7 to the power of C. This will be 7 to the power of A plus B minus C. The only thing is you can't simplify, but you just keep following the laws. Okay, Ayanda? So the same rules will apply. Same rules will apply. No, you can't simplify this. It will just be 7 to the power of A plus B minus C. Okay, I hope I've answered your question, Ayanda. I see a hand. Let's see if we have a question. Yes, Princess.
Hello, ma'am.
Hello.
Ma'am, I wanted to ask, so you saying 7A plus B minus C, will that be the answer, the final answer?
Yes, yes. Unless they tell you what A and B and C is, you can't simplify. Okay.
Yes, ma'am.
So if they tell you that A is 2 and B is 4 and C is that, then you can substitute. But if you don't know what the value is, you're just going to leave it as 7 to the power of A plus B minus C.
Thank you, ma'am.
You're welcome. That was a good question, Ayanda. Okay, your teachers might try and trick you with that one. I know I am going to steal that idea. So my learners have you to thank for that idea. Okay, seems like we all understand. So let's keep going. Let's keep going. If you have a variable and a number, same thing, okay? So 3 to the power of a multiplied by 3 squared will be 3 to the power of a plus 2. Same rules. Okay, so the rules don't change, guys. That's why you just have to learn the rules well, because they can't change and they won't change. And if you know them, then you're almost guaranteed to get these right. You just follow your rules and you follow them carefully, and you will be able to get these correct. Okay. No, remember when you're dividing, you subtract the exponents. Okay, I think it's for the previous example. When you divide, you subtract your exponents. So you can say a plus b over 7c, but then you're going to still end up with 7 to the power of a plus b minus c, because the c was at the bottom. You just have to make sure that they have the same base, and then you apply the same laws of exponents. Okay, let's do number I. Let's do number I. Things are getting a little bit heated, but it looks not bad, okay? So you need to identify your different pieces. We have an E there, another E, another E. Okay, we have numbers and we have D's. So we have D, D, and D. Okay, so let's start. In the numerator, can we simplify anything? Can we simplify anything in the numerator? We have 5D multiplied by 5E squared. That's why I had to check in now, Kalan. That's why I had to check in. Be careful, check the numbers, guys. Remember, this is normal multiplication. Can't we simplify the numbers? Can we simplify the numbers? What's 5 multiplied by 5? Yeah. Yes, Kimototo. So then in the numerator, we can only multiply the numbers, but we can't do much about the variables. There we go. So we're going to have 25 DE squared. We're done. Now we have a little bit of a problem in the denominator. Okay, let's check what's happening here. How do we do this? How do we do this? If you have multiple bases inside a bracket, let's say I have AB, and then I have an exponent outside. How do we do that? Does anyone remember how we do that? What happens to that exponent that it's outside? Okay, we can write it twice. Or laws of exponents say we can do what to the exponents? Yes, Amkhalang, we distribute it. So A gets a squared and B gets a squared. If we want to first write it out, it'll be AB times AB. That could be easier because then it'll be A times A, which is A squared, and B times B, which is B squared. But if you know the law of exponents, you don't have to go through all of this. You can just distribute your exponents. So let's distribute our exponents. I'm going to just write the first ED the way it is. Then I'm going to say times. So then 5 has to get a squared. E gets to get a squared. And D has to get a squared because we distributed our square. So every single base inside that bracket, yes, it applies to everything. Every single base has to get that exponent. All right. So now, let me move to the side here. We're going to need much more space for this. Okay. So now let's simplify my denominator. In the numerator, we still have 25 DE squared over. Okay, what's happening there? Now, how many E's do I have? No, let's start with the numbers. Start with the numbers. What's 5 squared? We're in the denominator now. What's 5 squared? Thank you. Squared. Remember, Rafile, not times 2. Squared is 25. 5 squared means 5 times 5. Okay. Now, let's start with the D's. How many D's do I write? What is my exponent for D in the denominator? We have to check how many we have. What is my exponent for D in the denominator? Thank you, Oratilwe. We are following. So we have 2 there, we have d squared and 1 over there. So in total, we have d cubed. Now let's talk about e. Let's talk about e. What is my exponent for e? Exponent for e? 3, because we have 2 there and 1 there again. So we have a 3. Beautiful. Let us simplify. Now we have 25 divided by 25. What is that? What happens to the 25s? What happens to the 25s? Yes, they cancel. They become 1. 25 goes into itself once. Numbers are gone. Let's deal with d. So it's going to be d to the power of what? They do cancel with each other. Yes, guys. Be careful, be careful. I know, you see why. They do not cancel each other out, guys. What's 1 minus 3? Remember, it's always the numerator minus the denominator, right? So it's going to be 1 minus 3. And e as well is going to be 2 minus 3. So that's going to be, thank you. So it's going to be d to the power of -2 and e to the power of what? Thanks, Amukhelang. I saw that. E to the power of -1. But we don't like negative exponents, guys. We don't like negative exponents. How do we make these exponents positive? Think of the rule of reciprocals that I told you about. We spoke about it. So how are we going to make these exponents positive? Yes, Sinobuhle. So we're going to take these to the denominator. So this will be 1 over d squared e. Okay. If you struggle with this concept, think about it. Remember, it was d over d times d times d, right? This d is going to cancel out with one of them, and 2 of them will be left in the denominator. Same with the e's. It's e times e in the numerator over e times e times e. This cancels with this one, this cancels with this one, and the one that's left over is left over in the denominator. So then it's 1 over. Yes, you guys are doing so well. You do the reciprocal, guys. Okay, so we get it. How was that, guys? How are we feeling about that? I think we can afford to do another one. Let me see what's on here. Okay, let's do these ones. Let's do these ones. We're stepping it up a little bit. I think we can afford to do 1 or 2 of these ones. Let's start with A. Let's start with A. Does this look familiar? This looks like the one we just did up there, right? This looks like the one we did up there. Yay, stop the bus. Let's step it up, guys. Let's step it up. So we have 3 to the power of x plus 1 minus 2 to the power, minus 2 times 3 to the power of x all over 3 to the power of x times 2. So here's how we do this one, guys. We want to take out 3 to the power of x as a common factor so that we can cancel it with the 1 in the denominator. Okay? At this moment, you cannot cancel it because of this symbol over here. We have a subtract over there. So there are 2 terms in the numerator. You are not allowed to cancel out. Okay, so we want to factor out 3 to the power of x, then we'll be able to cancel it. Okay, are we with me, guys? I hope we're with me. But first, we're going to have to split this up. So it's going to be 3 to the power of x times 3 to the power of 1 minus 2 times 3 to the power of x all over 3 to the power of x times 2. Okay, the rest I just rewrote as they are, guys. This one I split it up the same way I split up the one at the top. It's the opposite of law number 1. Law number 1 says if you're timesing, you add the exponents, but we want them to be separate, so we split them up. Okay, I hope you understand what I did there. All right, so now I'm gonna take it out as a common factor. So I'm going to take out 3 to the power of x as a common factor. Tell me, guys, on this first term, what will be left if I take out 3 to the power of x? What's left if I take out 3 to the power of x for the first one? 3. Look carefully, guys. It's 3 to the power of 1. So that's just 3. Minus. Second term, we're over here. If I take out 3 to the power of x, what's left? Nope. Let's look carefully, guys. It's 3 that's left, right? It's not 1. Kimotlo, do you have a question?
Ma'am, can I please ask? You know, the factorizing situation, you know, right, ma'am? So it says 3 to the power of x times 3. How come? Because 3 times 3 is going to give us 20, I think it's 27. 3 times 3. Oh, it's 9.
We can't multiply the basis because we don't know what x is. You see that? If you got the question and it was 3 to the power of x times 3 to the power of 1, what would you do? Would you multiply those 3's?
I'm not sure.
You would have to add the exponents. Do you remember that law?
I see. I see.
So now I just did it the opposite way because I wanted to split them so that I can take it out as a factor. You see?
Yes, ma'am. Thank you.
There you go. You're welcome. Guys, ask questions. Come on. If you have a question, ask. Okay, so here what's left is a 2, and this is all over 3 to the power of x times 2. I said x, but I wrote 2. Now you can cancel out, guys. 3 to the power of x can cancel with 3 to the power of x. And then what's 3 minus 2? What's left in the numerator? 3 minus 2 is how much? What's 3 minus 2? It's left in my numerator. We're going to have a 1 over what's left in my denominator. What's left in my denominator? Over 2. And that would be your final answer. Okay. Whew. I hope you guys enjoyed this lesson. I think I'm going to conclude it there. Teacher Coco will hopefully be back. Thank you guys for having me.